So we're asked to perform the integral. Again, it's with respect to x, and all of this is the equation. So looking at this to try and figure out what technique to integrate it with, one option would be to use integration by parts. And that's because we have an x tied up inside the cos that we're not able to get out, and we've got the x tied up in here outside in the bracket. So integration by parts is one method, and it definitely would work. The only problem with it is that you're going to have to do it a couple of times to drop the order of this first bit that you would let equal to u, because it's starting off with an x squared. So the first time that you apply the integration by parts, it would turn into an x. The second time that you apply integration by parts, it would turn into a constant. And that's good because then you're able to directly integrate what falls out of that equation. So while that's possible, for this question we actually have another option which is a bit easier, and that's to use integration by substitution. So how we can get that is if we look at what's inside here, which is the more kind of complicated bit of the equation. It's got higher order, or higher degree. What we can see is if we took the derivative of this, it's actually going to be equal to what's outside the front here in the bracket. So that's going to give us this little bit of a shortcut to use integration by substitution rather than integrating by parts multiple times. So that's going to be what I use in this question, but if you want a challenge, feel free to try and prove it using integration by parts. Alright, so to start off with, what we want to do is introduce a new variable, and I'm going to call it u, and we want u to equal the complicated bit of our equation. So that's this bit in here. Alright, so if we take the derivative of u with respect to x, we end up with 3 times 2 is 6, x, take 1 off the power, leaves us 2, and the derivative of that goes to 3. So, remember with this integration by substitution stuff, you want to make your equation here equal to dx, so that you can replace it back up in your original integral. So if I rearrange this for x, I'm going to get du, bring this down to the other side, so divided by 6x squared, take 3, and I multiply this up to the other side, which gives us dx. So let's go and substitute this in to our original integral. Alright, so dx is getting replaced with this. Alright, so what we can see here is we've got the 6x squared take 3 on top line and 6x squared take 3 on bottom line. So they're going to cancel with each other. And all that we're left with is the integral, and I should have replaced this, which I forgot. This is equal to u. Alright, so the integral of cos of u with respect to u. Alright, so now we should be able to just directly integrate it. So the integral of cos is equal to sine. Remember, you can check by taking the derivative. Derivative of sine is cos, right? And since it's an indefinite integral, meaning we have no bounds here, we need to have our plus c on the end of the equation. That's our integration constant. So now all that's left is probably to answer this question in terms of x, rather than this random variable u that we introduced. But we can go back pretty easily. We said u is equal to this stuff with x's in it. So sine 2x cubed take 3x plus c. So that there is the answer to the question. And hopefully you can see that's a lot easier than performing integration by parts multiple times. So always double check whether you can use the substitution stuff before commencing on a complex integration by parts. So that's all there is for this video, and I'll see you in another one.